Time is often treated as a natural cure for uncertainty. Hold long enough, the argument goes, and volatility will average out. This belief confuses two different things. Averaging across many samples stabilizes the estimate. It does not stabilize the path. A single trajectory moving through time does not benefit from the law of large numbers. For a process with independent increments, each step contributes its own variance to the total. The variance of the sum equals the sum of the variances. Over n steps, with increment variance sigma squared, total variance is n times sigma squared. Standard deviation scales as sigma root n. Neither quantity decreases over time. Time adds variance, it does not remove it. Independence of increments is the mechanism. When steps do not cancel each other out in expectation, their variances add without reduction. A process with zero mean increments still accumulates variance at every step. The mean returns to zero. The spread does not. Variance is not a deviation that corrects itself. It is a structural property of accumulation. Consider a random walk starting at 0. At time 1, paths lie within a range of order sigma. At time 4, within a range of order 2 sigma. At time 9, 3 sigma. The cone of uncertainty expands as the square root of time. No path converges to the origin in expectation. The spread grows permanently. The law of large numbers governs averages, not sums. The sample mean converges to the true mean as sample size grows. The position itself does not converge. An investor averaging returns over time gets a more precise estimate of expected return. The actual portfolio value still faces growing variance. What stabilizes and what is at risk are not the same object. Time can sharpen an estimate of the mean. It cannot reduce the variance of a position along a single path. For decisions made by a single agent following one trajectory, longer horizons mean greater accumulated variance. The expected payoff may be favorable. The realized path may not be. Time amplifies exposure. It does not absorb it. Variance scales as sigma squared times, t. Standard deviation scales as sigma root, t. These are not transient deviations that shrink with time. They are structural features of accumulation processes. No amount of weighting reduces the variance of a single trajectory. What time provides is not convergence of the path. It is only convergence of the sample mean.